Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a topic from the SAT and ACT that is as important to your success in the test as it is easy to forget about. It's one of those topics that's 95% familiar, but that 5% of unfamiliar is often enough to throw people off and cause them to make small mistakes which lead to incorrect responses. That topic is dividing fractions. Let's take a look. Okay, let's talk dividing fractions. The thing is, this isn't one of those fancy, complicated equations that everybody says you need to know to have a great score in the test. See your circle in a coordinate plane, ellipse, or quadratic equation, what have you. No, this is just some classic fourth grade division we're doing here, but just with a little twist to make it interesting. And so, before we get into the lesson, I'll ask you this. What is 10 divided by 1/2? Take a second and see if you know what that is. And so before I answer that, we'll sort of ask another question, which is dividing by a fraction is the same thing as what? And dividing by this fraction is the same thing as multiplying by the reciprocal being whatever that fraction is, just turned upside down. And so back to the original question with the numbers, let's look at some proof. First, we'll ask something that's really familiar, which is what is 10 divided by 2? Well, clearly 10 divided by 2 is 5. But at the same time, 10 divided by 2, and I've written that again as 10 divided by 2 over 1, and that's the same thing as 10 times 1 over 2, and 10 times 1/2 is 5, which is the same thing as 10 divided by 2, which is what that divide by symbol means, by the way. And so back to our question, and so hopefully this proves that whenever we divide, what we're doing is just taking that divisor, which in this case was 2 for my example, and then turning that fraction upside down, and then multiplying by whatever that new number is into the numerator. So if we were to divide 10 by 1/2, that's the same thing as multiplying 10 by 2 over 1, which is 20. So if you're dividing by a fraction, the number is going to get bigger instead of smaller. And that means if we want to go look at something a bit more complicated, so something like this stacked fraction here, where we have 3/4 divided by 6/13, all we would be doing is multiplying 3/4, our fraction on the top, by the fraction in the denominator, the 6/13, turned upside down. So that's just 3/4 multiplied by 13/6, which we can sort of take away that and call that 2 down there, and call that 1 on the top, and have 13 and on the numerator and 8 in the denominator. So this is a pretty straightforward topic, but what we've done with the example problems here is cranked the difficulty up a bit. So what we'll do now is look at some example problems and see if we can't apply this lesson. So they're both pretty big, so we'll just look at this first one first. Take a second and see if you can't figure this one out. Okay, let's take a look. We have x minus 3 over 4 divided by x squared minus 9 over 16, which is quite a bit. So what we'll do is, first of all, we'll just write our top fraction, and then we'll multiply by the bottom fraction turned upside down. So that's 16 over x squared minus 9. And the easy part here is just getting rid of the 4 and simplifying that to 4 in the numerator here to the right. And then the really interesting part is this is kind of a callback to a previous lesson on perfect squares and difference of squares. So we still have our 4 here, and then an x minus 3, and x squared minus 9 simplifies to x minus 3 times x plus 3. And so what we can actually do is cancel out the x minus 3's and be left with 4 over x plus 3. And the answer to that is C. So, like I said, a bit more complicated than just doing fractions, but the same concept still applies here. Hopefully that makes sense. Let's go ahead and do another practice problem. All right, take a second and see if you can't complete this one. All right, with this one, there's even more complicated items because we not only have fractions, but fractions and fractions, subtracting one from the other. So the way that I think is the best way to do this is sort of divide and conquer. We'll do the top first, and we'll sort of do the bottom separately. So n over 3 minus 1/2, we need to have a common denominator there, so common denominator for 3 and 2 is going to be 6, and so that's going to be n over 3 times 2 over 2 to get to 2n over 6, and then 1 over 2 is the same thing as 3 over 6, and so we can simplify that to just be 2n minus 3 over 6. And then for our denominator mess, if we have 2 over 3, that's going to be 8 over 12. And 1 over 4, that's going to be 3 over 12, for a total of 11 over 12. And basically, we're going to be dividing this thing by this thing, which means we can just flip that and multiply like we did with the previous problem. So we're going to have 2n minus 3 over 6 times 12 over 11. And these cancel out. We have a 2 right there. And that's going to give us 2 times n minus 3 over 11. So we can go ahead and get rid of this one that does not have a denominator. And 2 times 2n minus 3 is going to be 4n minus 6, which is D. So again, much more complicated than just doing a simple fraction divided by another fraction. But same concept applies here, it's just a few more steps. Okay, that's it for this video. An exciting little twist to something as boring and familiar as division, but with fractions, is an excellent illustration of the way that the SAT and ACT can make questions challenging while still adhering to their strict standards of limited, standardized material on these tests. If you found this material useful, please consider liking, sharing, and subscribing to Quad Education. Thank you for watching, and I hope you have a great day.